We are building the bit by bit project from the YByte Python curriculum available at www.ybyte.in. In the previous video, we created the basic infrastructure to create this LED pattern. Basically, we have on our screen written down, for example, B0 until B7, and we have, let's say, these LEDs being drawn. Right now, they are all white in color. Now, the next task is to, be able to specify a pattern, for example, 0 to 255, any number, figure out what the binary representation is, and accordingly turn on, let's say, the LEDs. For example, like I said, for 3, these two LEDs turn on because that's 00000000011, and likewise for 82, these 3 LEDs turn on. Now, while this is quite, let's say, simple in some sense for us to imagine what's going to happen, making a computer do this is requires some because we have to figure out what is the value of every bit, let's say, in this number. um, we will see how bitwise operators will help us. Let's let's start with a simpler problem that, let's say I have a pattern which is some number, b0 to b7. So like I said, all numbers are 8-bit numbers for us, so we are interested, let's say, in finding out what is the value of b3. Now recall, b3, just like any other bit, by the way, will be either 0 or 1. Now we want to find out whether b3 is 0 or 1. Now, using bitwise operators, this becomes quite interesting because what I can do is that I can say, okay, look, let me create a mask. This mask is all zeros, one at the location of B3, and then all zeros once again. Remember, and with a 0 results in a 0, which means that in the output, once I do a bitwise AND between the mask and the pattern, I will have zeros here, but I will have a B3 here because AND with the 1 leaves that bit completely unchanged. We have seen this before, which means that if it's 0, output here will be 0. If it's 1, output will be 1. So bit can be sort of obtained from here. Everything else will be 0. Now, I can then right shift this by, let's say, 3, and I'll have my B3 coming over here, all zeros, which means that this outcome, this, let's say the outcome of this right shift will be again either a 0 or a 1. So if it's 0, then I know B3 was 0. If it was 1, then I know B3 was, let's say, 1. Now, this basic idea can be basically, applied on all the bits. The only thing that changes, if I want to get the value of B0, well, the mask will have to change to, let's say, being 1 here and all zeros. If I want to get, let's say, B5, the mask will have to be, let's say, 1 here and all zeros. And that's what I've tried to sort of illustrate to you over here. Um, Basically, look, if I want to get 0th bit, I apply this mask. First bit, I want to get this mask, and so on and so forth. Now we can see this in many, many ways. First thing first, notice that this number itself is 1 left shift 0, which means I don't shift 1 at all because 1 itself is 0000001, 0001. If I left shift by 0, I get this. If I left shift by 1, I get this. Left shift by 2, I get this, and so on and so forth. Again, you see left shift working because I just shift the bit leftwards. I can also think of this as powers of 2, which is, well, this is 2 to the power 0, this is 2 to the power 1, because in decimal the value is actually 2, 4, 8, and so on and so forth. And that's what I've written here. So we are, the mask can be specified in many different ways, which means that we can do an operator, let's say to get, say, B3 again. We can say that, look, I am going to, do a bitwise AND between the pattern, which is what I want to represent, and 2 to the power of 3, which is like this, which is equivalent to saying that I'll do an AND with a between the pattern and 1 left shift by 3. So both of these are equivalent. Having done this, I will right shift this whole thing by 3 so that my this bit, whatever it is, comes to the lowest position. So that's the sort of the idea which I tried to illustrate here. Putting this in code becomes something like this. Think through this a little bit. Very interesting, good usage of bitwise operators. Let's now see this in code. So when I come to, let's say, my code over here, well, all I need to do really is to figure out, for every KK, what is the value of the bit, right? So first, of course, I create, let's say, a pattern. So I just create, let's say, pattern is maybe, is, let's say, uh, maybe, let's say, 81. Anything is fine. Now I just ask myself, okay, look, what is the value of that particular bit in the pattern, right? So what is the zeroth bit, what's the first bit, what's the second bit, and so on and so forth. I just define a variable called b. Now b is going to be either 0 or 1. As we have seen before, the way I'm going to do this is pattern. So pattern um, bitwise, and remember this ampersand is going to be bitwise and with 2 to the power of kk. Having done this, now be very careful with the brackets here. I'm going to shift this right by kk. Again, a bitwise operator. Now remember, this is basically saying that, look, find me that bit. Now, having obtained the value of the bit, in fact, now the situation is very similar to pixel art. I can go and say, look, if b is equal to 0, then, draw the square in white. Now, be careful of the indentations here. On the other hand, if b is equal to 1, well, draw me the square, let's say in red color, because for me, red would mean that the LED is on, right? So I just make this, let's say, red. Now, this is something which is actually very similar to pixel art, and really this is all we need, right? When I run this piece of code now, you notice that my pattern that has come up here is b0 is 1, b4 is 1, and b6 is 1. Let's try to verify this. If I were to look at, let's say, bin of say 81, let's look at this from the right side. So I've got a 1 here, which is correct. I've got 3 zeros, that's 0 0 0. Again, I've got a 1. I've got a 0 and then a 1 here, and of course the leading bit is then a 0. So this is now representing 81 perfectly correctly. Let's try one more pattern. Let's say I try 156. I'm just putting something here. When I Now this pattern turns out to be, let's say, something like this: 1001 1100. Let's try to verify this from our bin function. When I do this, it's 1001 1100 1001 1100. Very interesting how the bits are being represented, let's say, as these red color squares, kind of like LED lighting on, right? So nice kind of pattern here, right? Couple of things I want to mention here. One thing first, the first thing, remember, we could have done this equivalently completely using bitwise operators, and that would be possible by just saying that, look, shift this by kk. Now this is a very interesting expression, completely using bitwise operators. That's a kind of code you will see sometimes in embedded systems. What we are saying is that which is basically saying that, look, take one which is 0 0 0 0 0 0 0 0 0 1, shift it left by kk, and do a bitwise and with pattern. So which means that I'm getting bit number kk um, at its right location, because this is like my mask, like I said. Having done this, shift this whole thing to the right by kk. So I will get bit b. I'll get b being either 0 or 1, and the same thing will work. We can actually verify this. Let's just say I give a pattern to be, say, maybe 167, maybe. Yeah. So when I run this, you know, when we run this code, it's 10100111. Let's see if that adds up. So if I have 167, indeed it is 10100111. The reason is, what we are doing now to compare to what we were doing earlier is actually exactly the same. First one was using a little bit of mix of, let's say, bitwise and arithmetic operators. Here now we are using purely bitwise operators, and see the power of this. In fact, to see this even more vividly, we will specify the pattern directly in binary. Remember, I told you a more logical, more natural way of looking at the entire problem is to think in binary, think in individual bits. For example, right now I'm specifying 167. I had to go and verify that it's indeed correct. In fact, I won't have to do that. I can just go and say, well, look, 0b, let's say 10101101. Let's say this pattern. Now, really, I'm not sure immediately what this is in, let's say, in decimal. But if I were to do this, you notice my pattern that is lit up here is exactly this: 10101101. Because now we are really thinking in terms of bits. We are specifying which bit has to be specified. If I look at pattern, for example, here, it tells me pattern is 173, because bin of 173 is indeed 10101101. So this is another way of specifying an integer. And this is natural in our case right now, because like I said, every bit that is one is turned on, and we can directly start seeing this from here, right? That's why this is where bitwise operators become kind of handy. Now going forward, we'll make these patterns dynamic. It'll become even more interesting. I hope you're seeing the value of bitwise operators. Notice specifying the pattern in binary, and then using this kind of code, which is using bitwise operators to find out the value of every bit, accordingly lighting on the LED on and off. I think is very concisely done with bitwise operators compared to, let's say, any other method. And that's where this is valuable. As always, applying concepts to activities makes them interesting. We understand concepts much better. Look at our website, www.ypython.in, because that is how we learn Python programming. Take care. Thank you so much. Bye bye.